Good day, everyone. I want to welcome you to another class. So today we'll be talking about struct, which stands for structure. Struct help us to create data or help us to merge data together, collect data of different data types. So struct, we know that in real life, we always want to have data of an entity. So, for example, if I, as a student, am an entity and I want to get a record, right? So, I want to get a record of a student, then I need to know his name, CGP address, parent information, and that. All these data is tied together to a particular student. So, data structure, this struct, help us to organize our data and help us to group those data together to form a record. So for you to create structure, you have to use the keyword struct, followed by the structure tag name. So you can just say student, student. Then you open your parentheses, your curly brace, and you close your curly brace. You end it with a semicolon. Then inside, you have to specify the data you want, the fields you want, right? So I can say I want the name. We know name to be strings of character, right? So we can specify the size, all right? We can also specify the address. Let's say address. We'll specify the size. We can also specify, okay, what is the sex? Now, the sex will be a character. We just want to use a character for the sex, male or female. Let's say also CGPA. CGPA will be a float because it will have some decimal points. So CGPA. So let's just say these are just the basic information of a particular student. So it means this student, this struct tag becomes a data type. So because it becomes a data type, you can use it to create several variables. You can treat it the same way you treat your fundamental data types, right? So this student also is what we call our user-defined data type. Is user-defined. We are the one that created it, and it's user-defined, right? So the keyword is struct. You declare your struct tag name, followed by the fields you want to capture, and you end it with a semicolon. So with this now, what can we do? Then, because student is now a data type, you can now use it to create a variable, right? So this variable has the same blueprint, the same fields as this struct, right? So let's say I want to fill in my student. So what I will do is to fill in the name, I will use the string copy, right? Then I'll specify the name, the variable I want to fill, followed by the value. So I can do this, right? Oh, sorry. Now, it's not just name. It is student1 dot. So like I told you, it has the same blueprint. So it will be student1 dot name, right? So this student is, and let me use the word object of this of student. This student1 is an object of student, right? So it has the same blueprint. Is derived from students, right? So it has the same blueprint as what? As student. So student1, we have name, student1, we have address, student1, we have. So this entire field forms a record. So I can also do the same and say student1 dot address. So I can specify my address as, let's say, 10 Unilag Road. I can say 10 Unilag Road, Akoka. Right. So I've been able to fill in the students. So sex, I can say student one dot sex equals, let's say, male. Okay. I can also come here and say student1 dot CGPA is equal to, let's just say, is 4.990. Right. So I've been able to fill in data for students 1, right? So with this, if I also want to print it the same way, I can just use cout. I can just do this and do this. Student info, or I can just say student record. Sorry. Okay. Student record. Yeah. Can just new line, extra line. Then I come here, say cout, and just say student name and give it a tab. Student name. Then you can come here and copy the student name. All right, student name is that. Okay, you can say end line, come to a new line. I'm still using the cout. Students, let's say address. I'll give it a start tab. Student address could be student dot address. All right, still come. Students sex. Let's say student sex. Give it extra tab. Dot sex. Good. Then I can come here. Students CGPA. Student dots. CGPA. Okay, so end line. I end it with a semicolon now. Because I'm not done with using the cout, that's why I did not end it with a semicolon. So you can see I'm still using the same cout command. So with that, I can also come here, let's say, paste this. Come here, paste it. Okay. So let's run to see our output. So we just want to display the student's record. Okay, so let me give this extra tab spacing for alignments. All right. Wow, so this my entire record. Good. So I can also move this to a function so that we see how we use. So let's create a function to help us fill it. So let's say student, the function will return a value. Let's say fill student info, fill student info. I'm not passing anything to the function, but the function will help me, will fill this info for me. So I can come here. Let me cut it and paste it in the student info to help me fill it. So I'll zoom. So I can come here and create a variable, the student variable, student one. Yes. Yeah. So after I've filled this student one, I've filled it, then I can return. I can return the variable. So let's return the variable. Yes. So this function just help me fill the student info and return. So I can come here and call this function in the main function. So I can say student one, anything I fill from the function. So this function will help me fill details about the student, and it will be saved here. Oh, sorry. Okay, so it will help me fill. I'm coming this. All right, it will fill the students. So I can also create another function to help me print um print student info. Print student info. So print student info. So this the function is just going to print, so it's not returning any information. Then so anything I pass to these students will be printed out, right? So print student info. So let's call. So in the main function, I want to pass in student one. Okay. All right. So all what I'm trying to do is to show you that the same way we treat our fundamental data type, the same way you treat structure our own user-defined data type. So you can see inside there, I have a local variable called student one. So anything I pass to the student one will be received here, and I can then print it out. So let's go again. I've already defined the struct. I've created the user-defined data type student. And after defining the user-defined data type student, yes, so this becomes a data type, right? So with this data type, I can then use it to create a variable called student one. So here I have a fill student info function, which helps me fill the student information. It fills the student information. After filling it, it returns it. Because it's returning this variable, um, this struct called student1, the data type is student, right? Then, so whatever is returned from this field info will be saved where? Will be saved in student1. Then I can pass this student1 inside the print student info. When I pass it here, it's received by this argument. Then I can then print it out. So that's how I've been able to. So whatever you can actually do with your fundamental data type, you can see that the student tag name is used to create variable. Is used to create a variable. So let's run and see our outcome. Yeah, you can see it's still the same. It's still the same result. Now you can see what we did here is what we call by value. Call by value. Call by value. All right. So what if we want to do call by function, call by reference parameter? Yes. So we are using pointers. So if I have to use pointers, rather than this function helping me to fill and returning, what if I pass this function in, the student in here, I pass in student1, I pass in the address for it to be filled, address of student1. The reason why I'm having this is the argument, the filling student info does not have an argument. So what if I want to fill this student using pointers rather than using call by value? That is to say, rather than this fill student info returning a value, why can't I use pointers, the concept of pointers? So I have to modify my code. The essence is I want to show you that the same way you can use your fundamental data type, that's the same way you can students, let me just use student1. Then now if you have to use the pointer, the way you go about it is using this. First of all, the referencing, first you dereference the students, you dereference the student, then you now go to the name. You first of all go to that student1 location, and then you dereference it. You can see it's a whole lot of issue. You know, it's the best way to do that is just to come here and just use your right arrow operator. You can see right arrow operator, it solves that for you. So using the right arrow operator. So whenever you're using pointers, that's when you use your right arrow operator to help you do. So you don't need to use any return statements. So using pointers now, I've been able to do that. So you can see you first of all dereference where student1 is, then you now ask .name. Sometimes, most of the time, this can be confusing to students, right? It's always confusing to students. So the best way is just to use your right arrow operator. When you use your right arrow operator, then it's also the same way as the referencing. You can see, so the address of this struct, the address is passed. So you know if an address is passed, the only way I can receive the address is to use a pointer. And you can see it's being received by a pointer. Sorry. It's being received by a pointer. I don't need to. It's being received by a pointer then. is then dereferenced. So we're placing this in that location, placing this. So if I'm dereferencing it, it's still the same way I've been able to fill it in. So let's run and see if we are going to have the same result. Let's run and see. You can see we are having the same result. Yes, we have the same result. So that's the concept of using a struct. That's the concept of using a struct. Another thing we can also do when it comes to struct is we can have a struct within a struct. We can have a struct within a struct. So let me quickly show you that. Let me clear this screen. Let me clear this screen. Okay. Let's clear our code and say, okay, if we have a struct called student, and let's say a student took part in running. So let's say the student took part in running, maybe in a marathon race. Then I can create a record for those that took part in running and say, okay, I create an instance because this particular student took part in running. So then I can say, okay, student, student, my student, my student, right? Student, my student. And let me just say the time. Let me use the time float. Let me just use this. Okay. So you can see that we have a struct definition for a student. We have the student tag. We're now using it to create an instance within another struct. Within another struct. So you can see a struct being in another struct. It is important for you to know that before you can use this student struct, you must have defined it earlier. So let's just say, imagine I brought this student struct down, right? There might be some error maybe along the way when the compiler is compiling. So this have to be defined before we can actually use it in my student. Okay. So let me just show that. Let's imagine we have something like this and I'm trying to create my student. Let's see, student. Okay, let me grade this out. So you must have created the student struct before you can actually use it. You must have created it before. You can see it does not understand what student is. You can see student is unidentified. But the moment I create it, it's created, then it's identified. So I always love placing it before I can use it. So I can come here and say, okay, if you took part in running, so let's say this is the time. So you can see a struct embedded in another struct. So how do we use that? How do we use that? Now, so this is what happens. We already have a student struct. So let's say this is the name followed by the address, followed by the address, followed by the sex, followed by the CGPA. So CGPA, inside the runner struct, you have an instance called my student. So you can see this is my student. This is the definition for my student. Right? This is the definition for my student, which is inside the runner. So everything here now is the runner. So this is the runner record, having my student, which is this, and also having time. So apart from my student, you have time. So you have time, and the data type is float. You understand? So now the question is, how do we fill in the students my runner struct? So let's create an instance of the runner. Runner, let's say first runner. Runner is first. Let's just say the first runner. So how do we fill in the data? How do we fill in the data? So you can say string copy. Want to copy a string, want to fill in the name. So you say first, because that's the variable, dot, you can see, dot my student, yes, dot name, right? So that's it. You can also copy, might also want to fill in the address. So dot address. My student dot my first dot my student dot address. So road a coca. Then we want to fill in the sex. So the sex, you can just say first dot my student dot what sex, which is equal to male, right? Then you can print first dot my student dot CGPA equals, let's say 4.90. Then we have another field, first. Now, dot time. You can see dot time, which is equal to, let's say you ran for 40 seconds. I just say 40. Say 40. You can see we've been able to initialize our runner, our first runner. Yes, we've been able to fill in the data. Then we can actually print it out also, either using a function or just directly. So I can come here and just say cout, just say runner info, the same runner info, runner info, right? So new line, let's say new line, come to a new line twice, then you can print out. You can print out. Okay, what do we want to print out? Runner's name. So runner's name. Runner's name. Okay. So let me just give it. Runner's name. It will be what? First dot my student dot name. Okay. End line. End line. And I can also copy this. Runner's name. So runner's address dot address. Shift home, Control Shift home, Control C, Control V. Runners sex. So sex. Runners CGPA. I might decide not to even print the CGPA. So it's dependent on you. It is whatever you want to print. Time. So I can come here, the first dot time. Then I'm true. I might decide not to print the CGPA. So it is what you want that you print out. So let's run and see what we'll have. So we printed the name of the runner, we printed the address of the runner, sex, male, and this. So one beautiful thing is you can also create another variable, another record. So I say second. I say second, right? So runner first, runner second. You can also copy. You can also do the same way and say second, the same way you copy a variable, the value of a variable into another, and say runner equals second equals first. So it means I copy the entirety of what is in the first into the second. So I can come here and say, okay, second dot my student. So I can change everything and still have the same value. Yes. Because the entire record of the first is also copied into the second. Yes. 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 I can also multiply the time by 2. So times 2. To multiply the second just by 2, or I can come here and say after doing that, I can say second dot time or time multiply equals 2. So I have updated the time for this second variable by 2. And so I'm printing it out. So I should see that the time is now 40. Yes, the time is now 40. 80 rather. It was 40 before, is now 80. You can see. So whatever you can do to an ordinary variable, you can also do it to a struct variable. And also, whatever you can do with your fundamental data type, that's the same thing you can also do with your struct. Again, a quick recap. Struct will help you group together data, right? You want to collect data about a student name, student address, sex, CGPA. Although they are of different data type. Unlike array, in array, every record has to be of the same data type, but students of different data type, you can tie them together and they belong to a particular student. Yes, they belong to a particular student. So the keyword is struct. The keyword is struct, and this will be your struct tag name. So this struct tag name becomes a data type. Your own user defined. I'm the one that created this data type. Your own user defined data type, which you can now use to create an instance. So what we also have is a struct within a struct. You can see this struct, this runner struct, having the student struct, in it. So whenever you have your data type, what do you use your data type for? This becomes also your user-defined data type. What you use your data type for is to use it to create variable, to create an instance, right? So I use it to create two variables, first and second. I fill up the name. So first dot my student dot name, I fill it up. First dot my student dot address, first dot my student dot sex, CGPA, and the time. So you can see that the time, the hierarchy is just one level. So first dot time, 40. So what I did also is to copy all the data in the first into the second, just like the way you can do for variable, where you can say a particular variable, you copy the content to the same variable of the same data type. You can see they are of the same data type. But what I also now do is to multiply the time previously, which was 40, so by 2. So the time is now 80, and I printed it out. So that's it about struct. That's it about struct. I hope you've learned something today. So see you some other time.